All right, in this video, we're going to talk about what we call absolute value equations. At the top of this page, I give a definition, a very informal definition that states that an absolute value equation is an equation that contains a variable within absolute values. All right, and just as a reminder, absolute value is defined as the distance a quantity is from zero. All right, for instance, if we ever want to find that, let's say the absolute value of -5, well, since -5 is 5 units from zero, then we'd say that the absolute value of -5 is 5. Or we can do the absolute value of 5. Well, if I look on the number line, draw me a number line, plot the point 5, it is going to be 5 units from 0. And so that's what we mean by absolute value. It's the distance from 0. So when we come to solve absolute value equations, we have to keep that concept in mind. I have an example up here. It says solve the equation absolute value of x equals 3. Okay? Now what I'm asking here is I want to find what value or values of x is or are 3 units from 0. Okay, well, if you draw you a good old number line, if I do 0, and I'm just gonna, these are gonna be 1.1 unit increments. All right, and if I go 1, 2, 3 units to the right, I'll be at 3. And if I go 1, 2, 3 units to the left, I'll be at -3. So that tells me that if I want to know the solution to this absolute value equation here, it's going to be x equals 3. Or I could use x equals -3. So that means when I have an absolute value equation, I can possibly have two different solutions. This is what we're going to use each and every time we start to solve absolute value equations. We're going to take what's in the absolute value, and we're going to set it equal to the positive of this number sitting here, and we're going to set it equal to the negative, right? Because it's 3 units from 0, both of those numbers. The absolute value equations that we're going to be dealing with are going to be a little bit more involved. They're going to have more than just x within the absolute value. So we're going to have to take some other steps in order to help us solve those. And here are some steps here. The first thing I want to make sure is that I have my absolute value statement isolated. I don't want to have anything on the outside or on the side with the absolute value, just the absolute value and what's in it. After I do that, in order for me to solve the equation, I'm going to have to drop my absolute value by rewriting what my algebraic expression on the inside as two separate equations. Fumbling over my words here. And I have case 1 and case 2. There are two types of absolute value equations, so I'm going to do, it's going to look a little different, but we're going to be basically doing the same thing. Let's say that I have some algebraic expression inside the absolute value right here, and it's set it equal to a number. As long as that number is positive, then I'm going to do just exactly what I did with that absolute value equals of x, absolute value of x equals 3. I'm going to set it equal to the positive, and I'm going to set it equal to the negative. I've notated it here as taking what's on the inside, setting it equal to the positive of this value, and I set it equal to the negative. All right. The other case is when we have an algebraic expression on the inside, on the other side of our absolute value that involves the x. Since it's an algebraic expression and we don't know what x equals, we have to let it equal to the absolute value so that we can have like a positive as we do in this case over here. All right. And so when I have the absolute value on both sides, that means I have an algebraic expression on both sides, and I still do the same thing. I drop my absolute value by rewriting my two equations by setting it equal to the positive of what's over here and setting it equal to the negative of whatever's over here. Once I do that, I have two equations that I need to solve. I'll solve both of those equations, and then I can check my solution. Let's look at some examples. First example here. absolute value of 3x plus 8 equals 5. The first step is to isolate the absolute value. In this case, hey, I'm already isolated. So what I'm going to do is go to step 2. This is a positive number. So what I'm going to do is I'm going to take the 3x plus 8, that thing that's on equal on both sides, and I'm going to set it equal to the positive 5. Or I'm going to create another equation because my solution can come from setting it equal to negative 5. Now I have two separate equations that I can solve to give me two possible solutions. Let's solve this first equation. Okay, divide by 3. I'll get x equals negative 1. Okay. Same thing to solve this equation here. Subtract 8. And then we can divide both sides by 3. All right, and so my two possible solutions, now I can write them in a solution set like that, okay? And then, again, you can always check your solutions by plugging your values into your original equation for x and ensuring that you get a true statement still, okay? Let's look at another example. We have this example here. I have 2 times the absolute value of x minus 5 plus 9 equals 6. Now, this one doesn't just have the absolute value on one side completely by itself isolated. So I need to do that. All right, in order for me to isolate, what I do not want you to do is try to use the distributive property to distribute that 2 in there. All right, the distributive property only works if you have a parentheses, not an absolute value, right? The distributive property says, hey, if I'm multiplying a by a sum of 2 numbers, or a subtraction, right? You can separate it, take it out of the parentheses, and multiply like that. This is an absolute value here, so you can't do that. You have to go through your steps of isolating. First thing you do is subtract 9 from both sides. 2 times the absolute value of x minus 5 equals negative 3. And then we divide both sides by 2 since that's a 2 times the absolute value. We want those 2's to cancel, so we have to divide both sides by 2. And we get absolute value of x minus 5 equals negative 3 halves. Now, in order for me to continue here, I need to make sure that I have my absolute value completely isolated, and I also have to make sure that I have a positive number on the other side. This is negative, as you can see. And since it's negative, remember, absolute value represents distance, and distance from 0 can never be negative. Therefore, I'm going to stop in trying to solve this problem. I know that I have no solution. Okay? And remember, the symbol for no solution is the empty set. All right? So be careful. One thing you have to be careful about is not distributing here. And then another thing you have to be careful about is if you have your absolute value set equal to a negative number. We're going to go to one last example. And this example involves one where we have 2 algebraic expressions on both sides and both are in absolute value, right? Well, of course, they're both isolated. So what we're going to do here is, since they're isolated, I'm going to take what's in this absolute value here, 3x plus 5. And I'm going to set it equal to the positive, which is x minus 7, to give me one of my solutions. And I'm going to set it equal to the negative. Okay, I put this in parentheses because I have to do the negative of both the x and the minus 7. If I don't put a negative there, I'm only going to do the negative x. Okay, well, I'll solve these equations. They're just linear equations. Get my variables on one side. Get my values on the other side. And then I'm ready to completely isolate by dividing by 2. And so I get x equals negative 6 here. On my right-hand side, you can think of that being a 1 there if you want to. So you distribute this negative to both the x and the 7. So my left-hand side stays the same. And my right-hand side becomes negative x plus 7. Then we continue just like we would when we're dealing with linear equations here. Isolate that variable term. It's on one side by itself now. And completely isolate the variable itself. And we'd get that x equals, simplify that down to 1/2. As a solution set, -6, 1/2. Okay, and that concludes our study of, hey, absolute value equations.